So a quick proof of differentiation from first principles is that we're going to use our formula here, change in y over change in x, where x and y are variables. Variables screams change, and we've got a y2 minus y1 over x2 minus x1. That is all we're going to be using. So this is a formula that we've seen before. We can label that gradient, or we can label it slope. And this symbol here is delta. It comes from the Greek. It basically means change, capital delta. So if we draw two sets of axes here for our variables, y and x, and then we draw a curve on that axis. So this is y, x, and let's label a curve here, f of x. Therefore, we can take 2 points here. Let's pick our points here as x1, and x2, and then we have y1, y2, and if you draw a line between those 2 points, we want to find the gradient at this point here, which is the tangent to the curve there. Let's put that in another color, let's put that in pink. And so the tangent touches that point at just the curve at just 1 point, which is the definition of a tangent. And so if we now label these points here, x1 and y1, just simply as x, or let's put an arrow around that like that, x, and then x2 here is x plus h. Therefore, since we've got an f of x here, y becomes f of x, and y2 becomes f of x plus h. Therefore, using the formula above, what we're left with is f of x plus h minus f of x over x plus h minus x. And since the x cancel on the bottom, we've got x plus h minus f of x over h. So the last thing we want to do here is we want to see that this line here tends to that line there, as shown by my arrows there. And so in order to do that, for our differentiation, we want the limit as h tends to 0, which basically means that as x plus h tends to x, and we're going to label that as f dashed of x. And that there is our differentiation from first